I've written a small example application for people to get into Drools and start learning it, inspired by the adventures in Prologue over at the AMSI website. You can see the URL in the yellow box. For me, when I first saw this example, it's the first one I thought, wow, this is really cool. This is real declarative programming, and I've always thought about how we do this in Drools, and hopefully people can go through it and they'll think it's pretty cool as well, and learn from it. I also hope over time people get involved in the project and then expand it, increase its complexity, increase its size, which means us developers of Drools can learn from that too and try and improve Drools to make handling that size and complexity easier. When you first launch the game, you'll see this swing GUI. I'm not going to go into too much about the swing GUI. It uses MIG layouts. I tried using just default swing, but it was too hard to do form stuff. So I went with MIG and it worked really, really nicely. As you can see, it's got area for events, outputs. Although it's a text adventure, rather than typing in the text, I've got some buttons and we're going to build the commands that we're going to send to the engine. The first thing we need to do is select the character. There are currently two characters, the monster and the hero, so I'm about to select the hero. As you can see, we've selected the hero and it's emitting an event. Everything that happens in the game emits an event which is then consumed. We display that in the event window. We also use the events to update the string GUI, which I'll come into later on. As you can see, it shows that you are in the room, which is currently the ground floor hallway. You can see the items and umbrella, and it shows you the available exit. And it also uses in the items and exit menu as well, which we can use to build the command. So the first thing we're going to do is actually move the character, the hero, into the kitchen. Notice it does a string representation of the command that it's built before sending it, and when you want to send it, press send. So it's let us know that we're in the kitchen, which you can see in the output. Notice the enter and exit events have been published, and we can now see the items, the cucumber, and we can see the exit, so we can go to the basement or back to the ground floor hallway. If you happen to press the wrong button or the wrong items or exits, don't worry, you just press the command and it will clear the line and start again. We can send a look command to get a more detailed view of where we are currently. Now let's move to the basement. In the basement you'll see there are two items. One is another character, this one is the monster, and there's an item, mace. So let's pick up the mace. Notice the mace has been removed from the items list and is now in your inventory. Let's move the hero back to the kitchen, and now we're in the kitchen, let's drop the mace. Notice I select the mace from the inventory. With the mace dropped, it's no longer in our inventory, and you can now see it in the list of items. As I mentioned earlier, there are multiple characters in this game. You can play both the hero and the monster. So now let's select the monster. Notice the swing GUI was updated automatically. Again, this is all driven by events. When things happen, events happen, and that causes the GUI to be updated. You can see that we're currently in the basement. There are no items and there's one exit. If you remember, the hero moved the mace into the kitchen. Let's use the monster to go back into the kitchen to get the mace and move it back to the basement. We're in the kitchen. Notice the monster can see both the hero, the cucumber that was already there, and the mace that was dropped just recently. Let's pick it up and we can move back to the basement. What you've seen so far is quite simple just to get it started. But over time we can improve the complexity, we can build combat systems, more complex interaction between objects and characters. Should be a good learning exercise for both users and developers. The game can be launched from this text adventure class. This loads the adventure frame, which is a swing application, and also loads the game engine, which handles the loading of the rule files and the various states. The game engine loads the rule files such as model DRL, queries DRL, general, response, event, and also loads the state object into the engine. The model itself is actually defined in DRL, so here you can see things such as characters, items, rooms, and doors. Then we have state objects to declare where things are, what things are being held, and also to relate sessions, that's the GUI session, to the character. This is so we can actually have the GUI session switch between characters. As I mentioned earlier, everything in the game uses events, so we have a generic game engine event, then we have character selected events, exit events, enter events, pick up event, drop event, and we'll add more over time. As you saw, we don't have a text parser, instead we build up commands which we send to the GUI, and here you can see the move, drop, pick up, look, and set session command. The latter one is when you change the characters. I use envel to build up the model, so here you can see the rooms, the doors that connect the rooms. You need to clear the doors one way because we use a query to be able to get bi-directional access to that information. Finally, you can see the characters, the items, and the location of the items. We use Java to insert those objects into the engine. Now let's start to look at some actual rules. So first of all, we have queries.drl. So here I put some useful queries to get information. So connect, this allows us to get bi-directional access, so is one room connect the other? Whichever way you define the door, it'll return true. Is contained in, is one thing contained in another? We can query on the things in a room, the exit, or look, which combines the things in the exit. You can also see the inventory query at the bottom. Let's look at how some commands are processed. So the command comes into the engine. For instance, here is the look command, and it will execute the look query, and then it will bind against the data. And here it gets the things and the exits for the current character and the character's room, and it prints out a string saying you are in the, you can see the available exits are, and it puts into the response object and then sends that back to the session. When it receives a move command, you'll see that we look for invalid moves. An invalid move is you select a room that isn't possible to go to, and you have the valid move which actually does the action. Notice that on the valid move we create an exit and an enter event, and then we modify the location to move the character to the new location, and then we send a response back to the system letting it know that we're in the new room. That's the information that's outputted to the output area in the GUI. Here you can see the rules for valid pickup, but also invalid drop and valid drop. We've split the invalid and valid into multiple rules, but we hope to add sort of else-type functionality in the future, which means these rules can be combined into one. So let's look at the events DRL. So the first thing is you can see the print event. That means that every event that happens is sent to the events channel, which you see coming in the left side of the GUI. And then when the new character is selected, we look up the things and the exits for that character and the look query, and we also look up the inventory, and we populate the GUI with those via the various exit and things and inventory channels. When you move into a new room, as you saw, the emit an exit event, an enter event. When you have an enter event, it does a things query and an exit query, and then updates the GUI with those using the exits and things channel. But notice as well, you can see the on pickup and on the on drop events as well, which take care of updating the things in inventory for those events too. I hope you enjoyed that and you saw the power of declarative relational programming. Notice you just declare the rules, the data and the queries, and everything else just takes care of itself. To get some ideas of what you can do for a few other games, you've got the Interactive Fiction Archive, and of course the classic info game like Zork. You can get our latest code from GitHub, or if you don't want to build it yourself, you can always get the latest build of GitHub from Hudson. You'll actually need this to be able to run the example because it's just been checked in, and there are a number of fixes to the core engine which you need, particularly around backward chaining and queries. There's a user and developer main list you can use for your questions, or you can connect to our real-time IRC channel. All the core developers are there as well as users. You can just pop in and have a chat. Anyway, I hope you enjoyed this demonstration, and I look forward to seeing you online soon.